So this presentation today is about SIGTRAN, but more specifically about M2PA. So SIGTRAN is a grouping of specifications which have multiple things in there, right? So there is M2PA, but there's also M2UA, M3UA, V5UA, and IUA. But here specifically, we're going to talk about the M2PA variant of SIGTRAN. So we're going to go with the SIGTRAN M2PA overview, then more specifically what we support on the TelcoBridges products, then how to configure M2PA, how to look at the status, and how to troubleshoot M2PA. So the M2PA SIGTRAN protocol is used to terminate the SS7 signaling over IP. So instead of terminating normally like we have TDM MTP2 links, 64 kilobit per second links, we terminate using IP. These are the same messages that are carried over, but they're just over IP instead of over TDM. So to compare a TDM MTP2 link with an M2PA SIGTRAN link, it's on SIGTRAN, it's an IP and port, and on a TDM link, it's a trunk and time slot. So one time slot of an E1 or a T1 running at 64 or 56 kilobit per second. When you use M2PA, you have higher bandwidth, right? Because it runs on Ethernet, IP, so you have plenty of bandwidth. When you use MTP2 links, you're limited to 64K per link. So you usually need more than one link to have more bandwidth. Okay? So, but on M2PA, one link normally is enough. M2PA runs over IP, like I mentioned, but also SCTP. And the difference between SCTP and UDP and TCP, right? So UDP is no socket connection, so you just send data and it's not acknowledged. With TCP, you open a socket, you can send data, and it's acknowledged every time you send some data. With SCTP, the difference is you can have multiple streams inside the same socket. Each of these streams can have different priorities, and this allows for different information to be carried over the same connection. All of SIGTRAN protocols run over SCTP. There are two modes where we can use M2PA. First is the SSP mode, so that's a signaling point mode, and it's used to terminate ISOP or SCCP signaling. Here you see, I showed the diagram using TDM. So this is the traditional SS7 network architecture where you have your TDM, T1, E1s, and time slots, which carry those MTP2 links. Over MTP2, then you have two other protocols, MTP3 and ISOP or SCCP, running over that. I will come back to those protocols later. Now what we do is we replace those MTP2 links with M2PA here running over IP. So you have the Ethernet network here at the bottom, you have your SCTP and IP protocols, and M2PA is englobed in those IP packets. And you can receive data all the way to the ISOP mode. The other mode of operation for M2PA is signal transfer, where you have data coming in any network and be carried to another network over either M2PA, as we showed here, or MTP2. So this way you can do some TDM to IP conversions of packets. Right? So these are the same MTP3 level messages that are sent on both networks, but it's just the lower layer that is different between the two. Right? So above those MTP3 packets, you still have those ISOP and SCCP messages going by. Just to explain, ISOP here is to control specific voice circuit over a TDM network. And the SCCP here is to send data over SS7 network. A good example of a SCCP type function is SMS. So when you send a SMS, it will go over SS7. using TCAP and SCCP as encapsulation protocols. So if I look in the broader architecture, what it looks like, so those devices which support M2PA here need to have those higher layer protocol when you're in SSP mode, okay? And then you can do here call control, so you can control some channels and make some connections on the systems. You saw here at the M2PA level, it's running over IP. At the MTP3 level, you have link sets where you can bundle multiple M2PA or MTP2 links. And you have point codes here in a SS7 network. Each SSP and STP device have a point code. So each one of them have their point code, and we need to have our point code here as well, so that packets can be sent to us. When these packets are received, it could be sent here to eyes up to terminate voice circuits. So this is to control calls in SS7 network. The M2PA link can be connected straight to another SSP system. So then you can make calls straight end to end, or you can connect them to STPs. And in that case, these STPs have connections to multiple SSPs here, and you can send data to one STP, and then it can be routed to one or the other SSP in the network. Okay? For these devices, the configuration is the same. It's sending to STP or SSP. When you are using SSP mode, you also need to have media on those devices, okay? Because the eyes-up control we saw before controls voice circuits. So these voice circuits need to be connected somewhere. So for example, here you have some T1 or E1s connected to other SSPs, either directly or behind the STPs. That's what we can have here. So when we have your signaling that we saw on the slide before, you receive those signaling packets, and you can control those channels to decide how you're going to send media. It could be voice, could be data or fax on over those T1 E1 links here, or and normally in those networks today, what we do is we send these channels over voice over IP. So using RTP, UDP here to send the media. So the media would come from the TDM network, and then we can switch that out to the IP network, both ways like this. Okay, so you need to distinguish the signaling part, which is the M2PA and MTP3 and eyes-up protocols, and the voice. So the eyes-up is always to control voice TDM channels. When you go into the STP mode, okay, then you don't control voice channels here or media channels. Right? So you can get some traffic from SS7 and send that over the SIGTRAN network here. To be able to do this, you need to have a point code, right? So this device needs to have a point code because the packets are being sent to this STP, and then the STP can decide where to send those packets over the SIGTRAN network. Of course, it can go both ways, or it could be only MTP2, MTP3, multiple networks, or it could be only M2PA, MTP3 networks. All right? A lot of times, what we want to do is go from older TDM networks to newer IP networks, and this is why this model is shown. Okay? Then in this case, we relay all the traffic. And because we have the MTP3 layer here, we can also route the traffic. So packets that are coming from for this network, we can send here, but we can have also other networks connecting like this. So you have multiple routing possibilities at the MTP3 level. So if we look more specifically on the TelcoBridges device, what is supported, we have TMGs or media gateways, and we have the TSG modules, which are the signaling gateways. And you can see here TMG or TSG. So these are the same size of unit, but they have different capabilities. If you use the TMG ones, you always have the termination mode and the STP mode, which are supported. And up to the TMG 7800, these are smaller systems, and these are bigger systems. They support 64 M2PA links for the TMG 800, and the 3200 is 84 links, and the 7800 is up to 256. These are larger systems, of course. And then when you go to the TSG 800, it doesn't support the termination mode because for the termination mode, you need to have E1 or T1 circuits terminating inside the unit. So it can only support the STP mode when using M2P. To support M2PA and the TelcoBridges products, you need a specific license, which is called SS7 M2PA links, and it will say how many of those M2PA links you can support. So it could be 1, 2, 4, or up to 64 for a TSG or TMG 800. There are a few different configurations we can do when configuring M2PA. First one is the one up here. You need to have a local interface, so a local network interface, and your local IPN port. This goes through an IP link, and it's called here an M2PA link. And then you need to have the IPN port of the destination. Right? So this is a one-to-one connection we have here. However, we can also configure 2 different IPs for the same connection. So this is the same SCTP connection between the 2 devices, or sometimes it's being called an association when you talk in the SCTP world. So it's the same SCTP association, but you have 2 IPs. So this means if one of them goes down, the other one can be used as a destination. And this will switch automatically in the system. The other configuration you have, of course, is to have multiple network interfaces and different local IP ports sending to different networks. This is how you will interconnect multiple M2PA networks in the same environment. And here you can have up to 64 of those links configured in the system. Right? So you can interconnect a lot of them. So as you saw, the configuration, you need to have your local IP network, so local port, local IP. If you're using a VLAN, you can configure that. And if you want to have bonding, I will show you that in a minute. And then you have your M2PA link, which will be the remote IP, remote port. And the other thing we have to decide is on the protocol type. So anywhere in North America, we would use NC. In Japan, and the ITU is used almost everywhere else in the world. So it doesn't change much on the M2PA side to have these protocols, but it needs to match. And right? Now we're already in the configuration of the system. So when you log in initially into the system, you will need to select IP interfaces. This is how you will have your local M2PA IP interface. So there's 2 things you need to configure, the virtual ports and the IP interfaces. So the virtual ports are to create VLANs or use untagged networks and bonding. So you can go, you have your 5 or 6 here tabs. The first one here I skipped because on a TMG and TSG device, they're always configured. You can look at them, but there's nothing you can change there. You can just look at the status and the configuration of these ports. But here you can configure multiple virtual ports on a system. When you create here a new virtual port, let me go to the next slide. this is where you will choose how you want it configured. So you can put a name here. I put untagged, VoIP untagged here because my port is set to untag. If you remove this check mark, you will need to put a VLAN. I can show you this in my lab setup. And then you have your physical ports here. If you choose only one of them, it's going to be a single interface, but you can also use both ports here, and then you will have bonding between the two ports. So you see the virtual port configuration is simple. You just have to click Save at the bottom. Next is to configure the IP interfaces here in this tab. You need one IP interface for SIGTRAN traffic. So if you look at those interfaces you have in the system, you need to have at least one that shows services SIGTRAN. Because when you get into the SIGTRAN configuration, it will show only the interface that you have assigned to be of the SIGTRAN type services. So here you need to choose the virtual port we created. So you remember we created VoIP untag. So you create that. You create also the IP address. This will be your IP address for your system. And then you can put also the IP gateway here. Okay, so it's pretty simple. You can have multiple of those interfaces created on multiple VLANs, some bonded, some other bonded, some not bonded. I mean. Here you have other tabs, RTP port range. You won't need this for M2PA. Bondings here, you can see the status of the bonding when you click here. And tunnels will not be used in the M2PA configuration. So you only need to configure the virtual parts and the IP interfaces. Next, you need to go down to the SIGTRAN section of the unit and select SCTP. So you need to enable this SCTP layer. And the service type here, well, it's always raw IP. We have a choice of UDP as well, but we always use raw IP. In almost all the configurations of the system, we have additional information like advanced parameters here. For specific cases, you may want to adjust these parameters. And one example of this is if you're going through a satellite connection for this IP link, you may want to increase those heartbeat delays and responses, acknowledges. So we have documentation on how to do this. And then you have to open up those advanced parameters and you can change some of the timers in there. Otherwise, normally, if it's a regular connection, you don't need to change anything. Then you need to go to the M2PA section, which is down here. You need to enable this and the name here, well, we just put M2PA usually. And then you need to create service access points. Okay? So these service access points are your local interfaces to initiate M2PA connections. Okay? So if we go into this here, so when you select one of those service access points, you need to decide on which SCTP source port will the M2PA messages be sent from. 3565 is the default SCTP port for M2PA. So if you don't know which one will be used, you use this one. But actually, when you configure a system, you should always specify which port, which SCTP port you will be taking end to end. And for an additional note on this is that when you configure firewalls to pass on these firewalls or VPNs to pass on these M2PA links, you need to make sure it is allowed for SCTP traffic, not only TCP or UDP. Then you can choose the local IP interface. So this is the one we have configured just before, right? And then you just need to select those two arrows, and it will appear here. You press the two arrows, it appear there. So then these are the ones that will be used for your M2PA connection. And then you have on the bottom here the M2PA link. So here you need to specify the protocol type. The protocol type is, as you saw at UNC or Japan here. The destination port could be different than your source port. Again, if you don't know and you did not specify it, then you should use the default port. There's more chance it's going to work out of the box. And then you have your destination address where you will send those M2PA packets. Right? So, so that's the configuration for M2PA. Here you can specify multiple destination address. That's what the diagram I showed. So you can have multiple destination address for the same M2PA link. Or you can have multiple M2PA links here. So you can add more M2PA links with different destinations, and this will have different capabilities or reaching different networks. Once you've configured M2PA, well, it doesn't work by itself. So you need to configure the higher layer protocols, but it depends on which mode you want to use. Right? So for example, if you want to use STP mode, you need to configure MTP3. But if you want to use SSP mode, you need to configure MTP3 and ISO. Okay? So I'm not showing this part here because this is specifically for M2PA. There will be other presentations showing these upper layers. Then once you've configured what you need for your system, you will activate the configuration. So you need to go on system here and activate this configuration. You can also validate here to make sure you didn't make any mistakes in the configuration. Once it has been activated, right away, the link will be configured, it will be set up, and will come up, start sending packets over the network, and try to connect to the remote end. Once it has connected, then you can go here in the status and look at the global status of the system. The main one you will look at, of course, is the M2PA here. So if the M2PA is green, it means it has successfully connected to the remote side and is ready to be used. If this one is not green, then you could look here at the hardware unit section where you can see if the physical ports are connected and up, and if the IP interfaces also are connected and up. Right? So you'll be able to troubleshoot here at which level is this M2PA setting not working. If you have a 1+1 system, you can see this here. If you have your STP mode, you will also have needed to configure MTP3. You can see if that is up or not. And if you terminate, you can verify if your ISUP connection is also correct. And since I've configured ISUP, I also needed to configure TDM lines to have my voice traffic. For my demonstration, I also have a SIP network here, so I can send traffic from SS7, M2PA SS7 to SIP RT. Okay, so this is a quick check to see if everything is green like this, it means probably your system is up and running correctly. If some of the things are red, you can just click on there and dig deeper. You can also go, instead of going to the global status here, you can go more specifically to the IP interfaces or any other elements here in the configuration. And instead of using the configuration tab, you use the status tab. When you click here, you will see a global view of the physical parts, the status of the virtual parts, of the IP interfaces, and the bondings. And for example, in this case, it's IP interfaces, and you can see the MAC address of the interface that was used. What is the local IP address? Is it available? At what speed it's running? So you can have data on this. You can do the same thing for M2PA here. So you have M2PA, click on status, and then you have status of the service access point. There's not much information there, but if you click on links here, then you can see if my link is up, if it's disabled, and if other conditions are happening on the link. Okay, if you click on that M2PA link, then you will see the link control information. Okay, so you can have additional information about the link. You go down here, you can see, for example, the bandwidth. You have the current bandwidth, the peak bandwidth of those M2PA links. And you can also change the state of the link, right? So by default, when you configure a link, it will bring it up and make it work. But for testing, sometimes it's nice to disable it. For example, if you have a connection to M2PA links to do different STPs, and you want to make sure that traffic can go through each one of those STPs, then you will need to bring a link down. So then you press on yes here, and the link will go down, and you can see if the traffic goes on the other. The other thing I want to mention here is that when you select yes here to say, I want to disable the link, and then you click on apply states, this will apply immediately. It will apply the effect immediately. So the link will go down right away. So you don't need to activate the configuration. It will do that. So of course, once you finish your test, you need to put it back to no and apply states again to bring it back. Now I'm gonna skip to the lab setup. So for my lab setup, I needed to configure upper layers, MTP3. So I needed to add point codes, link sets, and MTP3 routes. I needed to configure a TDM line interface. I chose E1 for this case to be able to send voice traffic. And I needed to configure an ISAP layer to for configuring my circuit groups, which links the physical time slot with the virtual circuit group. So if I just show the lab setup here, so I have two systems like this connected together. The first system has an M2PA link using the IP 181. It has only one link set because I have only one M2PA link here. And I'm using the point code 701. And I have one circuit group configured here with 31 CIC because it's an E1 I have here. And these CICs are matched one-to-one to this E1. So CIC1 will be time slot 1 on this E1. On the other side, you see it's almost the same port, different IP, different point code. And then I can make calls between those two systems over the M2PA network. Here in my lab setup, I'm using a local IP network. You see both of them are local networks. Most likely, for a real deployment, you have a VPN connection over a public network or a private network to send your information. All right, so here I'm going to show the lab configuration. So here you connect to the web interface like this. This is a local port I have. You see here, you see the version that is currently running on the system. You see if your primary host or secondary host. This is a 1+1 system, but it works the same as a standalone unit. Here I created a specific configuration for the M2PA training. So I will go one by one here in my system. IP interfaces created for the system. So you see by default, it goes to the IP interface section, but I want to go to my virtual port and I configured this specifically VoIP untagged network here. And you can see here, I chose both ports to be bonded. Okay? Then you can choose here the units. It's a 1+1 unit. It shows only like the global system. And then if I want to go on a VLAN, then you can remove this and say I want to be on VLAN 1112, for example. And all the traffic will be tagged VLAN 1112 when it's sent out the M2PA. Okay, so it's a virtual port. And then the IP interface here, if I use my VoIP bonded, that's the one I use for my SIGTRAN connection. Here I must make sure there's SIGTRAN enabled. I could remove RTP SIP and keep only SIGTRAN, but I'm using it for other purposes in my system. The virtual part here is the one you need to make sure it's the right one, the one with either untagged or the VLAN you have selected, and your local IP and the gateway for this. Here, I don't need a gateway because this is a local network, but otherwise I would need to put the gateway here if it goes outside, maybe the gateway where you have your VPN network. And then that's it for the this part of the configuration. And then you have the M2PA. Well, actually, SCTP, I skipped it because there's nothing, you just have to select it. There's nothing else to configure there. But I mentioned before, well, there's no timers here. The timers are only in M2PA. So let me go to M2PA here. Yeah, you have an M2PA timer, so POL timers, for example. So these are advanced settings. Normally, we don't change them, but you could if there's some specific cases. Then we go to the M2PA SAP here. Click on that. So you have to create a new one when it's the first time you go there. Otherwise, you will get to this page here, and then you can put your source port. So it says also in the tooltip the default port for M2PA, but you can choose anything. And then you have other timers here for these M2PA connections. Actually, you see the SCTP timers are configurable per M2PA service access point. So you can have different SCTP configuration for different M2PAs. Here you have to put your default IP interface. So by default, it will be here on the right side like this. So you just select it and click on the left side, and it's going to be added to the local IP interfaces. So this is the interface from which you will send M2PA links. And then here you can create a new M2PA link. Here I already have one, so I can just click on that. You can choose your protocol type here. Destination, which could be different from your local one. Number of SCTP streams, well, it can match, but it's also auto-negotiated end-to-end, so they will decide how many streams will be used. This is like the maximum you would allow to use in a connection. Then here you have the IP address for the destination of the M2PA, but you could have another IP here that you can add into the system, and then it will use either one of them to send traffic. And in theory, your M2PA configuration is done. However, for my particular system, I had to configure higher layer elements to be able to send. So you saw in the diagram, I used my 2-point codes 701, 702 to send my traffic. And I had to configure a MTP3 network here of type ITU. And I have one link set, which has my M2PA link. So I can go here and see that I'm using the M2PA link that I'm sending. You can have up to 16 M2PA link per MTP3 link set. And then I have just 2 routes because there's one route going to the remote side, one route locally. So this is my MTP3 configuration. I needed also to configure my ISAP connection here. And because I want to terminate this ISAP traffic. So here I have there's not much here. I have the upper layers here, ISAP ITU, ITU variant, and then my circuit group here. So I have one interface going, and I have one circuit group, which has it's my E1 that is here. You see, I have one E1 configured in the system. So if I go back to the status here. So once it's configured, I will want to go here in system and activate this configuration. Oops. Here what I have is the overview of my system. So you can see if I have calls in the system currently. This is a 1+1 system, so I have 2 units here. You can look at the physical parts, see if they're connected. You can see if all the IP interfaces are ready. So it's a 1+1 system, and you see it's this one that is handling the traffic currently. And there was also, I wanted to show something else about the bonding. So you can't see the bonding here, but you can see it here if you click on bonding and status. You will see which port is active. So if you have a 1+1 system like this, a 1+1 connection, here we see it's VoIP 0 interface that's being used. If VoIP 0 fails, it's going to go to VoIP 1, and you'll see there will be a physical switchover count will be increasing here. So you know if the bonding has been switching. M2PA here. So you see you have your M2PA link. And you saw how much traffic there is on the link, and you can force it to be disabled here. I won't do this now. I'll show you later on how to do that. But we know we see it's green, and also the upper layers, you can see if they are running correctly. Okay. Did I want to show something else on that? I think up, down, no. Okay, so that's it for this. So let me go back to the presentation here. So when we have a MTP2 connection, it will try to bring up the connection. How it works, it will send data on the device. Part of it will be SCTP driven, part of it will be M2PA driven, different layers of the connection. One of the two sides will send an init on the M2PA link. It will specify here a window size and also number of SCTP streams. I showed you that. We'll be able to look at that in the trace as well. And we have the IP and port. So you have your local IP, local port, and the remote IP and remote port. So here you can verify if the init that you send is being sent on the correct endpoint. The other side, if it has accepted and if it's configured correctly, it will accept the connection with the init ACK. Could be different window size or number of streams, but they will agree on each other which one they will use. And then you have a cookie echo, cookie ACK, just a confirmation of the connection. Once that is done, it will start to configure the M2PA link. So, and if you've worked with MTP2 before, you will see that these are the same type of messages, out of service, alignment, see those same type of messages. And as soon as the alignment is done, it will test the link to make sure it's good. Okay? So when you have a proving emergency, it will send packets and make sure it's good. It's very important over networks because to make sure that all the packets are being sent and received. So it will test that link for a short period of time to make sure that there's no lost packets in the connection. This is proving emergencies for the first link, but if the second link comes up, then it will be a not proving emergency, but proving normal. And it will take more time to verify that the link is good. When you have proving emergency, you want to make it quick to bring the link up quick. So you test only a few packets to make sure it's running correctly. And then you get a ready message. So that means your M2PA link is available and ready to be used. After you have sent those M2PA message, you will see MTP3 level messages. You will see ISAP or SCCP messages being carried over that. So right now you saw my system is all up, but what happens if it's not completely up? Then you need to have troubleshooting time to figure out what is wrong with the system. So I would start with first checking the global status. You saw it's very easy. You can see if your local interfaces are up, if the M2PA link is up, or if even the upper layers are up. So you can have a good view of this. Normally, when it's all green, you're good. You have nothing else to do. If anything is red, then you need to verify. And for M2PA, there's not there's so many things you can check, right? For example, you want to see if you can reach the remote IP. So maybe if you're going through a VPN or a firewall or something like that, it could be blocked. So you need to be able to do an IP connection test. And this is the procedure: connect SSH to the unit. So you can't do it from the web portal. You need to connect with a secure connection to the unit. You do a telnet internal to the system, and then you can do a ping command. It's a bit different than the standard Linux ping command, but it does the same function. And I will show you this. The other troubleshooting you can do is the signaling trace. Right? So first you can connect to the SSH, connect SSH to the unit, and then type just TB-SIG trace. Type TB-SIG trace. Automatically, it starts, finds the M2PA information, and creates a M2PA capture file, which is viewable from Wireshark. This capture file, you can open it, and then you can look inside this Wireshark file to see, am I using the right IP? Am I using the right port? Are the packets flowing through and stuff like that? It's very useful. And this capture file is located in this particular directory, and I will show you how to do it. Both of these don't help you to fix the problem, then it's also possible to do a TB report. So you can go all the way down on the left side of the menu, create a report. You just type create here, click on create, and it will capture some logs, and then you can request help from our support group, and we will help you to solve your problem. And why we want the TB report on our side is that it has application logs for a specified amount of time from the system, but it has all kinds of information about the host of the system, the telecom unit configuration, and also a backup of the configuration that we can use to view your configuration. Right? So let me show you this on our system. Right, so first you need to connect SSH to the unit. If we want to do a ping, so we can do. So it's always the same internal IP for our system, right? 172.231.1.1 here, and then you can do your ping command, which I copy from the presentation. All right, so ping-b. This is my local IP, and this is my remote IP. Then you can see if it's up and running. You can, if you just type ping, you can have more information on what you can do with the ping here. And I use this one here, -b IP address. So it's a very simple connection, but you can also do, there's other functions that are available here, like trace route and other things. So you can see if that configuration is there. And there's also, for example, ifconfig-a, and you can see that your VoIP bonded interface is configured and available. Then the other thing you can do is your TB-SIG trace. So you have to get out of this telecom section and go back to our host section here. And then you can just type TB-SIG trace like this. Automatically, it will start this application and start capturing packets. You see here you have received and sent packets over that M2PA link, and it tells you which IP it has captured, which file has captured the data. Okay, so here what I want to do is generate a call, because I want to show you what it looks like. So I'll do this from my other system here, and you saw some packets here. To stop this application, you can do Q. Yes, stop this. Next is you can open a file transfer service like SFTP, FileZilla, or you can use WinSCP. And then you have to go to this folder. You saw the folder /lib/tb toolpack setup 12358 3.2 apps TB-SIG trace, and you will get to this basic trace folder here, and you see all the files that were created, and you saw the last one was IP 034. Of course, I'm doing a lot of tests on this system, so you can get this trace out of the system here, so that we can see it on our system. So if I just open it with Wireshark, just make it a bit bigger. This. So you see, this is my IP34 packet. So you see my SCTP connection is going between 181 to 160 heartbeat DAC, and it's continuously sending those packets. So here, what I created here is no heartbeat button. So chunk type 405 is removed from the from the connection. So this removes all the heartbeat which are unnecessary here. And you can see at this level M2PA packets. And you can see the upper layer packets as well, MTP3 messages and ISUP messages. And if I look at an ISUP message like this, and you open it up here at the bottom, you see the higher level, which tells you how to connect the call. But then you have your MTP3 level here, which has your point codes that are being used. And you have your M2PA, so MTP2 peer adaptation layer here, which tells you, actually, there's not much information. You have the forward sequence number, the backward sequence number here, the size of the full packet that is being sent here. There's some other information here from the M2PA. And you see it's running over the SCTP protocol using the ports we have configured in the system, 3565. Okay. The other thing you want to check here in this connection is my local and remote IP correct? So in this trace, you will see a lot of information to understand if your connection is correct, the IP, local remote ports, and then you can look at your higher layer protocols to see if your point codes are correct and if your circuit values are correct and stuff like that. Okay. Here, of course, it's a call, so it made a SIP call through the system. So if I go back to my configuration here of the system and I go to call trace, I can see the call that came in here, and it's actually a ISUP network here. It's an ISUP network here. It's an IAM, but the lower layer is M2PA. It doesn't show here because it's a very high level call from SS7 to SIP here. But we know that the lower layer is M2PA. We saw it in the trace. The other thing I wanted to show you was to bring down the link. So if we go to status and go to M2PA, all the way to our M2PA link, you can then disable the link like this. So if I go back to the status here, you can see now my M2PA link is down, right? It has been forced down by my setting. And if I put it back up, this, will come back green, showing it's ready. And I can show you a init trace. So for example, when the link comes back up, you will see the SCTP level messages here, init, and you see in those init messages, not a lot of information, the streams, the window size and stuff like that. Init ACK will confirm you have received this. Cookie echo is just an element here that is being confirmed. And then you have your out of service from one side, alignment, out of service, other side, alignment, proving emergency. You can see all of these at this level here, the traces. And then in the end, you will get your ready status. And as soon as it's ready from both sides, then you can see higher level messages that are being sent in the system. For example, signaling link test messages that are being sent, SLTMs, and response SLTA. So this confirms that the MTP3 level is up, and then there can be at higher level eyes up messages. Right? And maybe just here my TV report. So I clicked here at the bottom, report, and then you can create a snapshot. The default is for today, and then you can create this, and it creates a file. Depending on how much traffic or how much logs you have, it could be smaller or bigger here, and creates a report file. You can just download it and use that. And a lot of it can be analyzed by you because it's text based logs for most cases. All right, let me go back to the presentation here. Here I have put some documentation links that you can use for your knowledge, how to install the product in general, more specifically how to configure M2PA. And well, this is the M2PA overview. This is the M2PA configuration. And then you have troubleshooting. That's in general. If you want to troubleshoot different layers into the system, maybe IP links or E1s. And then you have links here to reach our support team, Team Media support. So let me show you this here. So product installation. So you have the TNG, TSG system. You have M2PA overview explained here. Configuration. So here, when you go into this page, you need to choose the correct one. So this is MTP2, MTP3 eyes up, but in our case, it would be M2PA, MTP3 eyes up. So this tells you how to configure everything into the system. This is what I showed, right? The M2PA section of the configuration. And then you just click on each one of them and you have helpers here. Once it's up and it's not working as you expected, you can use our troubleshooting guide. So there's all kinds of things you can do here for helping you. And then if that doesn't work, you can reach out to our support team, contacting our TP support team. We have our online trainings, which is what I'm doing now. It's going to be added here, and other information to help you, you know, install your systems. So this is it for our M2PA training. Thanks for attending.